I will now start on the Chapter 7 RStudio assignment. The first task for this assignment involves running a regression analysis using the LM function. So on line 1 here you can see that's what I've done. We're looking at whether or not pubs are a significant predictor of mortality. So I put the LM function. We're looking at the data set, pubs, and looking at specifically mortality, which is the outcome variable, and then once again pubs being the data set and pubs being the predictor variable. So whenever we run that and run it, and we're specifying that it's going to go into that specific object or value, and then we're going to take the summary of that model and look at that, and from this we could see that pubs are a significant predictor of mortality. We have a p-value of 0.016, and this model accounts for 65% of the variance in mortality. So it is a good predictor. Pubs are a good predictor of mortality. The next task first asks to do a multiple regression to see which variables predict supermodel salary. So you'll see, once again, using the LM function, the data set is called supermodel. The outcome variable that we're looking at is salary, and we're looking at specifically whether age, years, and beauty predict what a supermodel salary will be. So I'll go ahead and run that to create the model. And then run the summary of that so that we can see the information for that model. So you can see that the variables that predict model salary are age and years. And the overall model predicts approximately 18.4% of the variance in salary. So now we're going to look at how valid this model is, or whether or not we can trust it. So to do that, we'll be looking at a couple of different assumptions of multiple regression. The first test that I'm going to do is the Durbin-Watson test, which tests for whether or not the assumption of independent errors is true. So I'll go ahead and run that. You can see that the p-value for this is greater than 0.05, and the statistic is approximately 2. So this means that this assumption has been met. So now we'll look at the VIF function to look at the assumption of not having perfect multicollinearity. Let's go ahead and run that. So this gives the values of this statistic here, and you can see that for both age and years, the value is greater than 10. And if the value is greater than 10, this means that there could be problems with this model, and that the assumption of multicollinearity is not met, which, like I said, once again indicates a problem with the model. So next I'll be looking at a plot of the fitted values versus the residuals. And this is to look at heteroscedasticity as well as whether or not the residuals are normal, which are two more assumptions. So you can see in this graph here that this is quite a bit off from 0, which indicates a violation of the linearity assumption. And then the next graph, you can see it does a QQ plot next, and you can see that there's quite a bit of deviation here from normality in terms of the residuals. I'm also going to do a histogram to look at normality. You can see that the residuals are quite positively skewed, so they are not normal. So the errors are not normally distributed. So since several of these assumptions have not been met, I would say that no, we probably cannot trust this model. So for task 3, the first thing I'm going to do is conduct a hierarchical regression. I've entered parenting style and sibling aggression into the first model here. So I'm going to run that. And then I've entered all of the different variables into the second model. So that includes parenting style, television, computer games, sibling aggression, and diet. So I'm going to run that one as well. And run the summaries of both. As well as get the standardized parameters for the second model, as you can see there, and run a comparison between the two models using an ANOVA, which you can see right here on line 20. I'm going to go ahead and run that. So what all of this shows is that the model with all the variables in it does significantly increase the fit of the model from just having the parenting style to the and the sibling aggression. So adding the extra variables did in fact increase the fit of the model to the data. So the reason that we did the hierarchical regression was because theory and past research already indicated that parenting style and sibling aggression were good predictors of the level of aggression in the younger sibling. So in doing the hierarchical regression, we were looking at what was already shown and comparing our model to what was already shown to see if it added anything to being able to predict the aggression of the younger sibling. So based on this final model, which we do see is a significantly better fit than the first model, diet, sibling aggression, computer games, and parenting style are all predictors of aggression, which you can see. Let me scroll back up. Right here, the parenting style, computer games, sibling aggression, and diet. The only variable that did not predict was television. So this should cover everything in the Chapter 7 RStudio assignment.